Okay, so a few housekeeping items just before we get started here. Number one, uh, this this conference will be recorded. The recording will be posted to Inspires next to the solicitation. So if anyone missed it, or if anyone on y'all's teams missed it, and you think that they might behoove them to view it, it will be there for them. Also, the slides will be posted. Any questions that are asked here will be transcribed, and that transcription may be lightly edited for grammar and clarity, but will be posted on Inspires as well. NASA does reserve the right to make additions or edits to the answers in the transcribed version. So please do know that the transcribed version, the written document on Inspires, will supersede the answers given here if they conflict. Last item, and probably should have been the first item. My name is Ben Goodman. I'm helping to support exploration capabilities and space biology who have worked together on releasing the solicitation. This was originally released, the Phase A, under the Research Opportunities in Space Biology umbrella. Since that time, space biology has reorganized to the Science Mission Directorate, which is not really terribly important to you all, but it does mean that the current one is no longer being released under RosBio, but rather as a standalone, and the current one is the Phase B, and that is why, of course, we are here today. So that's my short housekeeping spiel. And with that said, I will turn it over to Ralph and Dinah.
Thanks, Ben. Appreciate it. Appreciate all your help in getting this pulled together. Good morning, everybody. Yes, we are here for the Phase B Pre-Proposers Conference. There'll be two presenters today, myself, Ralph Ritchie. I'm the Exploration Food System Project Manager for NASA at Kennedy. I will be going over the overview of the solicitation itself, and then we'll be following that up with Dinah Demopoulos, who's the OHALO Project Manager at KSC, and she'll be going over a short overview of the OHALO to hosted hardware ICD that's also attached as part of the solicitation on Inspires. We're looking to try to get through the first part of our overview presentation in about 30 minutes and leave the rest of that time open for questions and answers. Next page, please. So we're going to begin off with some boilerplate charts. A couple of things also from my perspective. I've been fighting off a really bad sinus infection for the past 4 weeks, so I'm going to probably take this a little slower than I normally would, just so I don't wind up getting into one of my periodic coughing fits. So Pre-Proposers Conference, again, boilerplates, the next couple of charts. This is really intended to provide any clarification that you folks might need in terms of the solicitation so that we can improve the quality and the timeliness and efficiency of the submissions that we get. It also allows us the opportunity to provide you all with some more information if it's appropriate, and emphasize existing information that's in the proposer, in the solicitation, so it may help you with your proposals. Again, as Ben alluded to, this is the chance for you guys to raise questions and receive answers. Again, the answers that will take precedence are the ones that will be written and documented after this meeting, as opposed to ones that may be provided during this meeting in case there's any difference. And again, you should all know that everyone who's here today has received a Phase A award for RosBio's Appendix C, and the presentation will be documented on the Inspires website at the conclusion of this meeting. Next, please. I'd also like to say, if at any time you have any questions throughout the presentation, feel free to jump in. Glad to try to answer them at the time you have them. We don't need to defer to the end. So for ground rules, we're going to make every attempt to answer questions during this teleconference to clarify the solicitation. I don't know that we have the opportunity to really engage in any sidebar discussions on the NASA side, so we'll kind of try to figure out how the best way to give you the most appropriate answer is during the meeting. Again, the key thing is that the ones that are documented afterwards will take precedence. And one of the big points as well is that while we're here to answer questions, we are not looking to provide any evaluations, opinions, or recommendations regarding your proposal. And again, the notice that this will be made available on the NSPIRE's website. Next. Okay, so we're all here for this notice of funding opportunity. And again, it's important to reemphasize the fact that this is funded by NASA Exploration Capabilities, which is a program within the Mars Campaign Development Division of ESDMD, the Exploration Systems Development Mission Directorate, a mouthful. The goal of this solicitation is to promote research and development projects that will lead to development of more reliable water and nutrient delivery concepts for growing plants and for multiple generations in microgravity. And that's a key part, is the multiple generations part. Periodically, we have grown one and done type of missions. And so we're looking really to extend into something more sustainable. The results of this Phase B should be a hardware design and development of a prototype unit for ground testing and evaluation. And we're also looking in Phase B to address solutions that optimize plant spacing and volume management, specifically in the context of an ISS Express Rack plant chamber. And that, for definition in this, is the hollow chamber, again, which we'll talk about the ICD afterwards. Important to note, as part of the sustainability aspect of things, we're looking for solutions that address reliability, ease of repair, and minimum supply of replacement parts. Next page, please. So let's talk a little bit about technical emphasis, and the first chart here is focusing on the water and nutrient delivery system aspect of the solicitation. Again, you're going to see that what I'm covering here in the next couple of charts will be repeated in some detail again. So it's one of those cases of us wanting to tell you what we want to tell you and then repeating that again later on. So systems, as part of this proposal, should contain the following items. We should be looking specifically for uniform wetting of plant roots and avoiding of any free release of water. We want to make sure we deliver adequate mineral nutrition over the life cycle of the crop. We want to maintain sufficient aeration and oxygen to the root zones. And we want to be able to quantify the amount of water and nutrients used by the plants over time, as well as maintaining an acceptable pH range for the roots, ideally between 5.5 and 6.5. And the system should be able to accommodate regular cleaning, refurbishment, sanitation, and removal of any unwanted residue in order to make sure that the produce that comes out of it is food safe. So again, along with that is minimizing the growth of undesirable microbes. Now, in case any of the proposals use a solid media, we want to stress that the media must be minimized in terms of the quantity used, and we want to see a demonstration of reusability of that media. And also specifically, we want to also understand what processes are being employed to prevent escaping of that media into the cabin or into the rest of the growth chamber. We also want to see that the resource requirements to produce the edible biomass has to be documented. And initial crops that we're looking at are for a variety of pick and eat crops. Root zone crops are desired, but not necessarily required for this. And the ability to recover root zone biomass, though, is highly desired. And as a result of that, proposals are encouraged to incorporate root zone research as part of this submission. Again, a focus here is on sustainable approaches with minimal consumables, something that we're really looking for and desiring. Next page, please. Now we're switching our emphasis over to the crop plant spacing part of this solicitation. And what we're doing here is we're looking for innovative concepts to optimize the use of the plant growth volume so that we can hopefully reduce the overall volume required to get the same biomass output, in case that's a constraint that we're under for future missions. So we're throwing out here just a few examples of the type of considerations that can be looked into for volume saving options. Things like separate nurseries or germination areas, seed handling, how you go ahead and do that, as well as transplanting, any mechanized spacing concepts or conveyor systems that actually track the growth of plants over time. Regardless, what we like to be able to do is take any of the expected area volume or energy savings incorporated in the concepts and give us an estimate of what those savings would be and include that as part of the proposal. It's understood that because of the small scale of Ohio, you might not be able to fully demonstrate volume optimization concepts in their entirety. And I think details of that are covered within the solicitation itself. So if you have any questions in that regard, I would have you go back to the solicitation. Next page. So just a general Phase B overview. We're looking at selecting up to 2 concepts to design and build a prototype water nutrient delivery system with variable spacing for growing plants in microgravity. Again, these concepts should be consistent with the Apollo plant growth chamber, and specifically in that context regards to the Ohio to hosted hardware ICD. Ohio will be providing the growth lighting, the environmental control, power, and recovered condensate water. The Ohio ICD does document the interfaces relating to structure, power, data, and fluid interfaces, so I'd have you look at that. And again, it is included on the NSPIRE site today. The final prototype, also important, it will be made available to NASA for performance and validation testing at the end of Phase B. Any questions on that? Okay, next page. So Phase B proposal required components. So basically, when we look at the Phase B award, we're expecting to validate the proposals and select them based on 2 main components. The first one would be a final Phase A document package, and the next would be the final Phase A presentation. For the document package, we're looking at a final report from you of the concept design, including preliminary engineering and science data, validating key components of the design and results of the investigation that you've currently gotten to at this point. For the Phase B proposal, again, it's to build a prototype system that addresses both the water nutrient delivery and the volume or plant spacing aspects. And then for the final Phase A presentation, that will be an outline of the results of your final report and key concepts of the Phase B proposal, and that will be delivered virtually at this point in time. One note I have there in the lower left is that while only PIs and organizations that won Phase A awards obviously are eligible to participate in Phase B, you can collaborate between Phase A awardees on a single Phase B proposal. That is allowed. Any questions on that? Okay, next page. So this is again a broad sweeping technical requirements summary. A lot of these things I've already addressed, but I'll be repeating them. First off is that the proposals need to address both plant water nutrient delivery and volume optimization. They should include plans for ground testing with relevant crops, along with a control to demonstrate the successful operation of the system. We're looking for you to plan a minimum of 2 growth demonstrations, one with the outrageous red romaine lettuce and one with red robin cherry tomatoes. The specifications of those growth parameters for those different tests are outlined in detail in the solicitation. The proposal shall describe an approach to measure shoot and root, if possible, biomass, shoot dimensions, water and nutrient use estimates. It should also address, very importantly, food safety to ensure the crops are safe for crew consumption. Looking for designs that mitigates plant stress and use food grade components, as well as approaches that minimize potential for pathogens. That's all encouraged as part of the proposals that are presented. Design shall consider ease of disassembly for cleaning and sanitation. We would like you to demonstrate the cleaning protocols, their efficacy, and the microbiological results. And resources used during the disinfection process should be quantified. Designs shall sanitize as necessary to ensure the production of food-safe crops. Again, we're looking for designs that strive for uniform wetting of the roots with no leakage of media, as mentioned before, if it's used, and delivery of adequate mineral nutrition and maintenance of sufficient aeration and oxygen to the roots. Again, design should be compatible with the Ohio Chamber ICD for dimensions, fluids, power, lighting, and air as required. And all resources in and out of the system should be tracked. And importantly, proposals should seek to minimize crew time for both nominal and maintenance and cleaning operations. And again, sustainability is important. So we would like to look at proposals that look in the proposals for things that minimize the need for spares and supplies. Next page. Okay, what's the proposal review criteria? Proposal is going to be reviewed for technical merit, approach and feasibility, relevance and responsiveness to the notice of funding opportunity, technical plan, expertise of the teams involved, the facilities, and the cost, and that will be done by a peer review panel. And then it's also going to be looked at for programmatic alignment, overall cost, and feasibility. Next page. Okay, that concludes my portion of the presentation. Is there anything that we want to go back and any questions asked before we turn it over to Dinah for the ICD walkthrough?
Yeah, I had a question. This is Jonathan Singer from Rutgers University. Can you hear me?
Yes.
With regards to, and let me know if I should hold this for the end, but the Phase A proposal requirement, are we allowed to build our team at this stage to incorporate other organizations? And is there a required breakdown? Like, that wouldn't make sense. It would be 1% the Phase A team, but are there any guidelines or limitations there?
Ben, I don't know the answer to that specifically. That seems to be a solicitation general question. Would you have any insight into that?
So based on the eligibility, you would have the proposal itself has to come from the same organization that would receive the Phase A award. So they would have to be the lead organization. I don't believe that there is a requirement for the percentage effort from that organization versus other ones. The key thing is that the Phase B should be leveraging the findings from the Phase A. So the Phase A organization has to be involved.
Right. I didn't see anything in the fact that addressed that specific scenario. So I would defer to that. Again, look at the frequently asked questions in a little bit more detail and see if you can ascertain the answer to your question within that.
Oh, okay, so I had sent that question. Maybe that was added since I last looked. Thank you.
Anything else?
Ralph, hi, this is Murat Kisira from.
Hi, Murat. How are you doing?
Hi, very good. Thank you. And please get well soon.
Thank you.
Thank you for the information, Ralph. I have a question here. You mentioned about various things, specifications required for Phase B, then water nutrient delivery, nursery requirement, mechanized way of moving the materials. And I know that Ohalo has a specific volume and size requirement. Were you referring to be able to accomplish all of that in a scale?
No, so I think when you look back at that, especially within the detail that's in the solicitation, those are just examples of the types of spacing opportunities that could be looked into. We're not driving you to any one of those or all of those as a path forward.
Okay. Are you looking for specifics, design aspects that are incorporated into the Ohalo unit within the design component?
I think at this time, we're not looking for how you would incorporate that into Ohalo. We're looking for what your thoughts are for spacing ideas in general. It might be that if it goes past this into a procurement, it might be something we would want to entertain within Ohalo. So I would keep that in mind, but I don't know that there's a tight constraint to having the solutions you work up with being something that we can easily integrate within Ohalo.
Okay. All right. Thank you.
Anyone else? Okay, and I think before I turn it over to Dinah, I just want to again stress the dates, that the fact that the Phase B proposals are due on August 31st of 2022, and right now the selection date we're looking at is October 31st, 2022. Okay, so with that, I'd like to turn it over to Dinah Demopoulos, the project manager at Kennedy Space Center for Ohalo payload, and she's going to go over the ICD in a high level of detail. I think we've already had these discussions with each of the teams before in more detail, but this is an opportunity if you've got anything else that you are uncertain about. Thank you very much.
Thank you, Ralph. Thank you for the introduction. And yes, everyone, my name is Dinah Demopoulos. I know a few of you already. Um, and as Ralph had mentioned, I will be going over an overview of the hosted hardware interface control document. Again, as mentioned, it is part of your NSPIRE's attachment, so always refer to the document if you have further questions, or we can answer them at a later time. But right now, Ralph has actually gone over a good majority of this in his previous slides, but let's see. We want to note that the attachment in NSPIRE's for the ICD, the hosted hardware ICD, is actually in draft. It's not a baseline document. It's still subject to change as we continue to design our hardware. So please do note that. So not everything is concrete and set in stone just yet, but as they become available, we'll have a final version at a later date, and awardees will be notified of that. And we have 6 major modules in our OHALO payload. We have the power and electronics, and as you note, if you read the ICD, we do name our subsystems based on Greek gods. We have Zeus, our power and electronics module, and Zeus actually manages electrical power distribution within OHALO, and it also serves as our command and data handling hub. Then we have Aeolus, which is our environmental control module. And this module controls the atmospheric conditions, such as temperature, relative humidity. It also has the capability to recover excess water vapor and for storage and reuse, so it recycles the water. Then we have our Poseidon module. That is our water module. This module controls the storage and the distribution of both clean water and liquid nutrient solution. Then we have, fourth down, we have our growth chamber, who we call Gaia. And Gaia is actually where your hosted hardware will be going into. This is the growth chamber. And then we also have our next Greek god, Helios, and that is our 2 lighting systems, which will provide the lights to your plants. And then last but not least, we have Atlas. And Atlas actually provides the support structure. It is the strong back that our payload attaches to the Express Rack in ISS. So next slide, please. Again, as I just mentioned, OHALO is a sub-rack payload installed on the Express Rack. We have we have to adhere to ISS requirements, and we have the standard interface requirements documents for pressurized payloads, and that's called out in SSP 57000. And then we have our safety requirements that we need to that are levied on us as well, and that can be found on SSP 51721. OHALO mechanical interfaces. We have in the ICD, we document and specify the chamber dimensions. We also specify keep-out zones within the growth chambers. And these keep-out zones are mentioned so because we plan on putting fans in certain locations, and we just want to make sure that there's no disruption or interference between your hosted hardware and what's within the growth chamber. It also specifies chamber access, where your attach points will be. We have the faceplate panel specifications are also called out in the ICD, and the interior attachment points. So the next bullet, so that covers mostly the mechanical portion. Now we go into electrical interfaces. So the hosted hardware will be interfaced with utility interface panel number 7. Please bear with me. Electrical is not my background. I have a background in mechanical, but what I do know is that this electrical interface is, here we specify the power interface, the voltage levels, we have overload protection, and electrical bonding. Next slide. And here is a pictorial, rough pictorial of how the command and handling interfaces are handled. This is the high-level architecture. And again, I mentioned the data interface, the data storage, the data system access, and more of that is also called out, the specifics in the ICD. And so now we go into our fluid interfaces. So this is Poseidon. Poseidon holds the water. We hold up to 7.4 liters of liquid storage, and actually is divided equally between clean water and liquid nutrient, and that's giving that 3.7 liters each of capacity. Poseidon also enables the filling, draining, and sampling operations of both the clean water and the nutrient storage bags via connectors in the front panel. So Poseidon has front panel connectors. Poseidon also provides the means to transfer the clean water to the nutrient side. This will give it the capability to dilute any nutrient solution that is supplied to the nutrient side. So if any dilution is required, Poseidon provides that capability. Again, I didn't mention the 2 physical interfaces. We also have fluid services within Ohalo that will withstand a maximum design pressure of 63.4 psi. So we're requesting that the host hardware meets those standards, and it's dialed down to each level within the ICD. Next slide, please. And continuing on, again, this is kind of a reiteration of what I've already said. Clean water interface, we have the liquid nutrient interface. This fluid schematics also found in the ICD. It takes time to go through, but you can follow it. And if you guys have any other further questions, please feel free to come back to us and ask questions. Next slide, please. The environmental interfaces. So here, again, as mentioned, controllable atmospheric within its growth chamber. We control the temperature, relative humidity, airflow. Then with chamber lighting, we also have 2 sets of independently controlled Helios light modules. And also have control over parameters, and they are also specified in the ICD. Next chart. Is there a next chart?
I think that's it, Dinah.
I think that's it.
Okay, I thought so, but I got thrown off because it says continued. Oh, meaning it was continued from the previous. I'm sorry.
Correct.
I got thrown off on the left. But yes, so that actually gives a quick summary overview of what's in our ICD. If you guys have any questions or comments.
This is Scott Jones, Utah State. I have a question about so the Ohalo system is duplicated, is that right? Or is there redundancy among all of the systems?
I don't think I understand the questions. You mean duplicated, meaning do we have two Ohalo systems on
Yes.
board? Yes. The plan is to send two units.
And so there's no common, there's nothing that's shared between those two units.
Shared, you mean they act as standalone units?
Okay, so
I think the question is, they're independent, are they
Yes.
independent of each other? And the answer is yes.
okay. Another question. In years ago, there was often an opportunity to go to parabolic flight to test some of the systems without gravity. Is that an option here?
Is it? So I'm going to try to repeat your questions just so I know I understand it. Are you asking if there's an opportunity for your design to be flown on a parabolic flight?
Yes.
I don't think I have the answer to
Yeah,
that question.
that wouldn't be for you to answer, Dinah. I don't know that in any of the discussions I've been in, we've talked about parabolic flight testing of any of the system design concepts that would go into a Phase B proposal. And Denise, I know you're on the line. I don't know if you recall any conversations along that line.
Yeah, I think if something like that were to happen, that would be something that the proposer organization might need to or coordinate themselves. And so I think it's something that we would need to look into a little bit more to give you a full answer.
Thank you.
And so, Ben and Denise, that's all we had here for the presentation for today. I think we've addressed all the questions that have been asked, but Denise, I don't know if you have any closing words you'd like to offer at this point in time.
Just that we're really excited to see what types of concepts you guys can come up with, and to help really make the Ohalo mission successful. And this is a very important activity for our future Mars transit hub and exploration needs. So I'm excited to see what comes in at the end of August and what selections we have in October. And thank you for all your time and hard work on this.
Thank you, Dennis. Ralph, I have one more question here. You mentioned about the ability of the system to account for the resources, monitoring all the resources. Are we going to integrate that into the hosted hardware? Or we should expect that to be also done through the Ohalo structure itself? I mean, are we looking for an autonomous monitoring of all the resources that the system is using?
The way, and I think we'll take this one back for further clarification, but the way I read it is that from the design that you come up with in a standalone fashion, you need to be able to account for all of the inputs as well as all of the outputs of that system concept that's part of your design.
Great, thank you.
Yeah, I had a question regarding this is Oscar Monje from Amentum. I was looking at the requirements, the SSP 5700 and SSP 51721. Those have to be, so any design that we make that's going to go into a hollow, it has to fit within those specifications. And then there's also going to be a fit check for the final, well, if awarded, there's going to be a fit check on Ohalo?
I know that from the design perspective, you would have to meet the higher level requirements that are specified by the space station program. I don't recall an Ohalo fit check seeing that in there. That might be my oversight. Denise, I don't know if we talked about that. As far as I know, that would be something that I did not catch that in the solicitation.
That would not be part of Phase B.
Right, that would be an afterward if we were to try to go ahead and do a procurement, I would have assumed.
Yeah, and that's not part of the topic of this discussion
Correct.
today. I think with the ISS requirements, those are more, looking forward as you're looking at your design concepts. These are the things that would have to be met if you do fly on ISS, but it's not required to be met for Phase B.
Correct. That's forward-looking things as well as the materials compatibility, that type of thing.
This is John Singer again. In the ICD, there's mention of Ohalo cameras, and these were also mentioned in an earlier meeting. Do we have a timeline for when we might get specifications for the Ohalo cameras in terms of their resolution and kind of image frequency and things like that?
So for camera information, we do not have those specifications just yet. Since the cameras are always changing in technology and getting better and better each time, we've kind of put, not that we've forgotten about that, we've concentrated more on other things, and we didn't drive down specifications for a camera. There are cameras in place as far as what we're using temporarily, but we already know that's not going to be our final camera choice.
I guess, is there any way to get sort of a minimum baseline just based on what you guys are using and testing, and like the sense that the camera will be no less than this or something, just so we can, for some of the mass predictions or something like that, if we want to use that information, would it be possible to just get some sense?
I can work with the team and see if we can provide something for you and the rest of the PIs. Yes, I'll take that action.
Thank you. That would be appreciated.
This is Oscar again. On the Ohalo fluid interface diagram, there's nutrient water bags are available on and do you have volumes for that, and are those available for us to use, and is that what would have to be coordinated with a Ohalo team?
So Oscar, is your question whether or not water bags are going to be available for you? I think this is more, it's not going to be a Phase B question. It's more an operational question once you get, once the hosted hardware is selected. I don't know what your question is driving.
Yeah, I agree. Oscar, I guess one of the things to think about is, as I see excuse me, a flurry of ICD questions come in, is to make sure you sift through those questions in regards to what's required for Phase B rather than something beyond Phase B. And if we need to have a discussion about future, potential, awards and what that would mean for something integrated into the Ohalo payload, maybe we default that to another time.
Yeah, maybe I got confused in the question, in the way I asked the question. What I was trying to get at is there is a nutrient bag shown over here in the diagram, and if we want to be able to use that particular volume, during our design, what would be the volume of that, and is it available for us to use in our design? Like, for example,
So
whether we fly or not.
Okay, so what you're seeing here in the fluid schematics, I think I understand your question. So this, so so the water bag and the nutrient bag that you're seeing in this diagram are within the Ohalo payload. So it's built in. It serves as storage capacity within the payload. So it's not something that's mobile. So this really has no connection with the hosted hardware. This just explains how fluid flows within Ohalo. Where the connections to hosted hardware is basically you have your clean water. It's the bottom, and you have this front interface, front interface, front interface. That's where we connect like the water bag or the nutrient solution bags to introduce water into, or the nutrient solution into the Ohalo system. That's like for filling ops. I don't know if I answered your question, Oscar, but
Well, but I mean, in the diagram, right? If you have your clean water, which is condensate water, right? And you
yes,
have that 1, 2, 3, 4, 5, 6 valve,
yes,
then that goes into hosted hardware. If and then if you look, it's the same thing for the nutrient water.
yes.
You know, is there any potential way of commanding that valve to use that nutrient water bag, 2 valves away? That's what I was getting at. If you can draw from the nutrient water tank, you can probably draw water from that nutrient water bag. I'm just asking if that's possible. If it's not available, that's fine. That was the question.
Okay. Yeah, that would be a design question, but that acts as a storage. That nutrient water bag on the bottom is all within Atlas, within Poseidon. Those are just storage within the modules. So and when you add them all together, it's 3.7 liters total.
Okay, thank you.
You're welcome.
So Diana, to clarify, the hosted hardware will draw from that bag, correct?
Correct. It draws from it draws from the bag to the pump to the hosted hardware. So as you start using the nutrient from the pump on the clean water pump and the nutrient water pump, as those deplete, we start filling back the pump with the solutions that's stored within the water bags and the nutrient bags.
So this is Scott Jones again. To follow up on Oscar's question, let's assume there's air bubbles in the water or nutrient. Are those going to be handled by Ohalo? Or
Yes, we understand that that's an issue. There's a filling operations that will help mitigate those air bubbles. It's still in the middle of design. We're still factoring that in, but that is the goal.
Okay, and then if we provide a nutrient dry, let's say in a water soluble bag, how would that be introduced, or do you have plans for how to create the nutrient solution?
So if you're creating a nutrient solution and you have it in a bag, and it needs to be dissolved and diluted. I'm not sure. We're still in the middle of the design. I can't say we can use, and we might have to stick with just liquid. It depends on what kind of. I don't have the answer for you just yet because we don't have that.
Okay.
We don't
Yeah,
have a development unit.
we are working on our own nutrient solution. So our anticipation is that you would want us to fly that dry and then mix it up there, but you can
Yeah.
work on a solution to that.
That's how ISS program would want us to do it, correct?
Okay.
We have
Yeah,
one question
Oscar.
in the chat.
Oh,
I'm sorry, what was the question?
So a question in the chat: if the hosted hardware has its own pumps, can it draw liquid directly from the water bag, bypassing the water pump? That's from Dan Wyman.
From bypass the, so from host, there is a port in the host. If you have a port in your hosted hardware to just introduce water directly to your hardware from the front panel interface, that will be on the hosted hardware if you want that capability.
So I think he's claiming that his hosted hardware, if the hosted hardware has its own pumps, can it draw directly from the water bag instead of having to go through the clean water pump?
No, I'm not following the question. I'm sorry.
Dan, is your microphone working?
Can the nutrient water pump recover liquid from the hosted hardware?
Can they use their own pumps to draw water from the nutrient bag and not use?
He was asking about the
Your
water bag,
valves.
not the nutrient bag.
Oh,
Oh, okay. The chat said nutrient water pump. I'm sorry, I'm still not understanding the question, and I feel
I
like
see,
this
yeah.
is a question. I feel like this question needs to be answered. I need to go back to the design team to fully, give you a good answer.
Sorry, we got two questions in there.
Sorry, I was trying to get my my mic and audio setup correct without getting an echo here. This is Dan Wyman. So the first question I asked was whether if the hosted hardware has its own pumps, would it be able to draw directly from the water bags bypassing the clean water pump? So basically just having the hosted hardware's pump setting the flow rates and pressure, and instead of relying on Ohalo to provide the liquid flow. And that actually would apply both with the clean water and the nutrient water separately.
So what you're asking, if I'm hearing you correctly, is that is it possible for the hosted hardware to provide their own water and nutrients introduction into the hosted hardware, and that Ohalo would just be supplying the other environmental conditions like the lighting, the relative humidity, and etc.
Not quite. I'm asking if there is, with the valve connection there, like those 5-spoked valves, is there a connection that just goes directly from the water bag to the interface to the hosted hardware, so that the hosted hardware can pull water directly from the water bag instead of having it go from the water pump into the hosted hardware?
No, the only connection the hosted hardware has to the nutrient is through that interface. The front do you see the two gray squares? And
Yes, I see those. It's more of a valve design question. Whether I may need to follow up
yeah,
outside of this to clarify specifically what I'm asking for that one.
okay. It's just one way, and that's, you're getting it through that connector.
Yes. So I I can hold off on that and follow up later.
Okay.
The other question I have, it looks like there's a check valve for the clean water pump, but on the nutrient water pump side, is that a bidirectional connection? Can it deliver nutrient and recover liquid from the hosted hardware, or
So
is it one direction?
it's bidirectional on the liquid nutrient side, and it's unidirectional flow on the clean water side.
Copy. Thank you.
You're welcome.
Dinah, Oscar again, one last question.
Yes.
So using that bidirectional and the nutrient water pump from Poseidon, that would be how to get rid of waste produced in the hosted hardware. And would that go into that nutrient supply? Is that how you would get rid of some waste to be discarded, liquid waste?
Liquid waste from
the hosted hardware. So yeah, so let's say I got ink in my hosted hardware and I want to get rid of it because I want to dispose of it. I would use the nutrient pump from Poseidon through that front inlet, and would that be disposed into some sort of bag taken away by the crew?
Yes, well, we would recommend that you have 2 ports in your hosted hardware and in the front panel where you could do that. Let's look more into the ICD for those specifics. But it is, I do know it's bidirectional. I'm still trying to understand all its capabilities. But I would be happy to post all these questions and have them captured, and we can answer and distribute amongst all the PIs.
Okay, thank you.
Yes, you're welcome. Do we have any more?
I guess with regards to the collection of questions, I just want to confirm that we should be using the single email given in the call for any questions we have following up on this or any other documents, or will we be put in contact with specific people for specific questions?
Use the general email, please.
Yes, thank you.
Another question regarding clean water and nutrient solution. Is there some mixing mechanism if you're adding both at the same time, or do those go in separately? Or we would have to do that mixing?
There's water. You mean mixing within the nutrient water pump, or are you saying mixing it like
So are those 2 separate interfaces? So we get one interface for nutrient solution and one for water?
Yes.
Okay, that answers my question. Thank you.
Thank you.
One more question from chat. How do you from Phil Sadler? How do you support an aeroponics approach?
Who was that question directed to?
I believe you.
And your question,
Phil, did you want to expound on that a little?
Yeah, this looks like it's focused on a porous tube approach, and we're looking at an aeroponics approach.
So Phil, it's not focused on any one approach. It's the interface to the hosted hardware that we're looking for responses to this solicitation to design. We're not trying to lead the witness in that case, in any way, shape, or form.
Well, good. I'm just curious.
So right, I mean, what we're trying to tell you in this diagram is that you have a interface to the hosted hardware to receive clean water, and you also have an interface to receive nutrients. So however you want to build and design your hosted hardware, those are the two things that Ohalo can provide in terms of fluid.
All right. Any further questions? I think we're coming to the end of the hour.
I wanted to go back to the one question about the suborbital flight and just get a little bit better clarification of what that question was so that we can answer it
So
quickly.
that was my question. Basically, if you want to test, some of the requirements that you don't have porous media coming out of the system or wetting the substrate without gravity, one of the ways to do that would be the 20 seconds or so of reduced gravity on a parabolic flight. And I realized NASA had that resource and it was probably easier to provide that. But I guess what I'm hearing is we would have to budget that and arrange that ourselves if we wanted to do that.
That's what I believe the answer is. I don't think NASA's providing those kinds of flights specifically for this purpose, but I think we can need to check into the options for how you would do that.
Right. NASA doesn't have an aircraft that does that dedicated anymore. We work through the Flight Opportunities Program, and they subcontract out the aircraft, the flight time and the topics. So that would be a whole other organization that would have to be brought into the scheme of things to see how that would be enabled, so to speak.
Okay.
And the thing that I'm not sure on, because I'm working both CLIPS and Blue Origin flights and I get confused, but there may be, opportunities for commercial manifests there that NASA's not involved in, but I would need to check on that. And then, yes, that would have to come out of your budget.
Okay. Can you provide that contact information if it's up to us to arrange that?
Yes, we can do that.
All right. Thanks.
I guess just to follow up to that, with the new world we live in, there are the opportunities that Blue Origin and Virgin provide. But if you're looking for repetitive parabolas, so to speak, then that would be via aircraft, and that would be Flight Opportunities Program. So I guess there are options. You'd have to understand the nature and the amount of time or iterations of that time that you would want for that test.
So I should note that if so Flight Opportunities is a separate program that gives money for doing suborbital and parabolic flights. To my understanding, there was nothing in the solicitation that required a suborbital or parabolic flight or provided for NASA providing one of those. So it would have to fit under your budget if you were planning to do it as part of your Phase B.
Right,
If you
that's how
have
I
a
would see
separate
it.
award from Tech Flights, you could certainly leverage that.
That's a great answer, Ben. That's what I would have expected. Thank you.
I had the contact information if you wanted to pursue that on your own.
I think we might be out of cycle on Tech Flights this round, so that might be a future consideration. But
And also not knowing what the duration is, you could also consider drop towers, things like that, like out of Glen.
A Flight Opportunities gives you about 2 minutes of, I guess, yeah, 2 minutes of flight time.
Yeah, I think
Test time.
For 0G flights, you're looking at roughly 28, 30-second parabolas. And, depending on weather, you could get up to 40 parabolas a flight, but it could be substantially less than that, depending on weather and other customers, that kind of thing.
All right. Any further questions? If not, then we'll go ahead and wrap this up unless Denise, Steina, Ralph, did you have any final words?
No, I just appreciate everybody tying in today and the nature of the questions, and look forward to receiving the proposals when they come in.
And thanks, Ben, for hosting.
Yes, thank you to all. I hope I was able to answer some of those questions for you, and if not, please submit any.
And Ben, I assume that you have a list of the attendees and all the questions after the meeting?
Yep. So we will be posting the slides and the recording fairly early next week, and the transcription will follow hopefully a little later next week. We'll give the program will have a chance to look it over and make any additions or edits to the answers before we post that.
Thank you,
Those will
everyone.
be posted to
Thank you.
Nspires?
Yes, it would post it to the same website where you access the solicitation. Yes.
Thank you.
Thank you very much for your time and all the information.
Bye.
And with that, I think we are adjourned.